All right, thank you everyone again for joining this next iteration of the iNPUT-ACE training events for video evidence. We took a bit of a pause for the holidays, so we're excited to be back at it for the new year and keep up with these training events. Today's event was generated and spurred by a number of questions that we received over the past few weeks and months about HEX analysis and using HEX to read and understand video files. We've touched on this in some past training webinars, and what we're going to do today is dive a little bit deeper into what HEX is, how to read it on a very basic level, and how to understand it on a basic level. With this topic is going to come a bit of a wide range of people that are attending the webinar and as far as their understanding of this goes. Some people are going to have no experience with HEX. Some people are going to be very familiar with HEX from a digital forensics perspective. So we're going to start slow, teach everyone what the basics are before we get into looking at some video files. One of the challenges with this particular webinar is going to be that we're going to be looking at some very small numbers in a HEX reader. So if you're using a small monitor, you might want to consider zooming into this webinar so you can see the numbers and characters in detail. I'm going to have a member of our team here post in the chat log how you can zoom in. It will require that you have the GoToMeeting client downloaded on your end. But if you're having trouble looking at the specific numbers that I'm referring to here, that might be a helpful way to get started. So what is HEX and what is data on a computer to begin with? You've probably all seen footage like this. It's going to look like the Matrix. We're going to have a bunch of ones and zeros scattered throughout a file that contain all of the data inside of that file. Every single computer file is nothing more than a sequence of ones and zeros, ons and offs in a pattern that a computer can interpret and understand all of the complex things that we can have a computer do for us, from things ranging from calculating mathematics to viewing video files. Everything is going to be a pattern of ones and zeros, and how we read those ones and zeros is what gives way to all of the complex types of files that we can have. To start looking at that though, when you view a file as its ones and zeros, that can be very challenging to understand what it is from a human reading those ones and zeros. So to make that a little bit easier for us, I'm going to launch a HEX reader and look at a file from its raw level, viewing its binary data and viewing other information about the file. I'm going to do that by dragging in first a completely empty file. This file has a 0 size. There is no data in this file at all. And if I go back to my Explorer here and I open up my properties, we can see that it has 0 bytes of data. For those of you unfamiliar, a byte is a series of 8 bits. A bit is either a 1 or a 0. So a single 1 in a file is a single bit of data. A single 0 is a single bit of data. 8 of these together equals a byte. What looking at a HEX reader will allow us to do is see that information in another way and interpret those ones and zeros in another way that will help us read the file and understand more about it. So for example, if I type in 00, 00 here in this hexadecimal view equals a single byte of data, or 8 bits of data. 2 characters in HEX is going to be equal to 8 individual ones or zeros. So the HEX value 00 is the 8-bit value 00000000. If I type in a 01 in HEX, that is the 8-bit value of 00000001. If I type in 02 in HEX, yes, that is going to be 00000010. If you don't understand anything about binary data at this point before starting this webinar, after you've watched this webinar, it might be worth going through and reading through some basic Google articles on Wikipedia to understand more about how this counts. I'm going to gloss over some of that for now with an expectation that most of you are already familiar with that. The part that's going to really matter for us more than the binary values are going to be things like the integer values, what the actual numerical value of that hex value equals. So a 0, 3 in hex is the numerical value 3. A 0, 4 in hex is going to be numerical value 4. As I begin to add more and more values to my hex here, we can see that a 9 is indeed the value 9. However, there is the next instance of a value in hex is not going to be 10. It's going to be 0a. And we can see that that integer value here is 10. So hex counts kind of in a funny way compared to what we're used to when reading typical numerical values, at least in our Western world. So if I type in here all of these different values, all the way up to a maximum of f, we've counted all the way through to 15. So 0, 0, 0, 1, all the way through to the 0a, b, c, d, e, f. There is no g in hex. Now what we have to do is increment the other character by typing in 1, 0. So now we have our first row done all the way to 0f, which is value 15, and then 1, 0 is going to be value 16. Instead of going through all of this manually here and doing all of this live, I've got a pre-produced file here that counts all the way as far as we can go inside of hex. And that looks like this here. So we've basically continued that pattern all the way through and written in all of the rows for each of the available hex values all the way through the file, counting up to a maximum of FF. So we range now from a 0, 0 through to an FF, and we can see if we look at our integer value here, as I use my arrow keys to go and move forward one by one by one, we can see that the integer value increases by 1. 13, 14, 15, 16, 17, 18, 19, 20, all the way through this file here. And if I continue to go forward quickly by holding my arrow key down and I land somewhere randomly in the file, I can see that a 9C hex is going to be an integer value of 156 or a binary value of 100111100. So why does this matter? What is the purpose of all of this? Well, one of the purposes is that, again, looking at these ones and zeros, like the matrix, is really hard to look at. A human's not going to be able to look at a large pattern of ones and zeros and make any understanding of what that means. We can look at some of these hex patterns and learn what they mean, but even more than that, we can let a computer interpret what that character means by looking through essentially a dictionary and identifying and decoding what that value is. So the hex value 46 can be decoded by the computer to be an integer of 70 if the computer is using a dictionary that is understanding numerical values in this particular format. But it can also look at another kind of way of interpreting the file by looking at it in its ASCII characters here. So the value 46 in an ASCII character right here is going to be the capital letter F. So this might be a bit confusing. I'm going to repeat that one more time before we start to look at video files, and hopefully it'll make a little more sense at that point. In essence, computers are made up of binary values. We can read those binary values by looking at individual hex characters that equate to 8 binary values in a particular sequence. Another way of interpreting those values is by looking at an ASCII character for that value, which in this case would be F. And then even another way of looking at that character would be a numerical value of the value 70. Let's look at a more common kind of file by looking at what a notepad file contains. So I'm going to open up this file right here, and we can see that all I've done is created a brand new notepad file and typed in the characters. This is an example of a simple text file. If I were to look at this inside of a hex reader, and I drag that file directly in, what we'll see is that each of these individual hex values, each byte of hex equates to each individual character through the file. And that's all we have in the entire file, straight through. And if I go back and I look here at my all hex values, I could highlight any one of these characters, and I can see that 73 is being interpreted as my S in my notepad file. And if I look at my all hex values here and I find 73, sure enough, it equates to S. The size of this file is going to be nothing more than the number of bytes inside of the file. So to simplify that a little bit, let's go back to my folder here and let's make a brand new file. It's going to be a text document that's going to have just simply one character in it. And if I open up this one character.txt file, currently it has 0 bytes of data. It's completely empty. And if all I typed in was the capital letter X and then saved this file, what we'll see is if I open up my properties to this, if I open up my properties to this, we can see that it has exactly 1 byte of data, which again is 8 bits, 8 ones or zeros. And if I drag that file directly into HEX, we will see that that single byte of data is the hex value 58, or the capital letter X if we interpret it as ASCII. Now that we have this basic understanding of what HEX is showing us, let's take a look at something a little bit more complicated, which is video files and how video files are going to be read and understood when viewing them through a HEX reader. Now we no longer have individual bytes of data or small strings of bytes of data that are notepad files. Now we have things like a video file that is a total of 154,509,026 bytes. That's quite a bit of data, at least as compared to notepad files, and is going to be challenging for us to look through the ones and zeros and understand very much about it. So now, instead of being interested in the individual bytes themselves and using those to interpret them like what their ASCII characters would be, for example, now what we have to use is a different kind of dictionary to understand this file in a more complicated way. So what I mean by that is, I don't necessarily, in this case, care that that value is an ASCII H and an individual value 68. Any one of these individual values isn't going to mean anything by itself. What we need to use now is a sort of dictionary to read patterns of these ones and zeros and begin to understand what those ones and zeros mean. Going back to my analogy of by what I mean when I talk about a dictionary, when we look at a notepad file, that dictionary is something as simple as understand what this means as ASCII. But when I talk about a dictionary as far as a video file goes, that analogy is referring to is a codec. What is the codec going to read these patterns of ones and zeros to begin to understand what the frame dimensions are, what the picture values look like? And we can use tools, like in this case, I'm going to use iNPUT-ACE here to open up and drag and drop this file directly into iNPUT-ACE to allow iNPUT-ACE to do that process automatically for me by understanding automatically that the dictionary or codec to use is H.264, understand what the pixel format is, understand what the pixel dimensions are, and even begin to build and understand what the individual frames themselves look like very, very quickly. But what's happening under the hood is quite a bit more complex than that. What's happening under the hood is that iNPUT-ACE is looking through those ones and zeros and finding standard patterns that equate to the H.264 standardization or standard codec. I'm going to gloss over this section a bit here, so we're not going to go into the weeds about what these patterns are, but I'm going to focus this entire webinar on one very common form of H.264, which is in Annex B. And that very standardized form of H.264 has a very common pattern. And that pattern is going to be a sequence of bytes, which are 00000167, followed by some data, followed by another sequence of bytes, 00000168, and some data, sometimes a 00000106, and then a 00000165, followed by a lot of data. This sequence right here, which is referred to as a sequence parameter set and picture parameter set, followed by some additional metadata. I'm not going to go into the details of that. You can think of this like a header or the data that starts before an iframe. So all of this data that we have selected right here is nothing to do with individual picture values like colors of pixels, but has everything to do with information that is required to then interpret those picture values. And we can see this pattern repeat throughout the file whenever there's an iframe. So if I do a quick search by hitting my Control F key, I'm going to do a find of hex values, and I'm going to find 00000167. That's that initial sequence that we see that starts off before the NAL unit, or really before we get to the iframe. So if I say OK, I can see that here's the next instance of that pattern. And again, we see the 00000167, followed by the 00000168, followed by the 06, and then by the 65 before we have our data. If I search to the next instance, and the hotkey for that in this particular program is F3, I can press my F3 key and snap down to each iframe throughout the file in sequence. And I'm snapping down through all the iframes. We can do that another way by toggling back into iNPUT-ACE. I'm going to drag that file here back into the program. And let's use the program here to give us even more information about the file. I'm going to just snap somewhere here in the middle of the file and find my next instance of my iframe, which is we can see here labeled in our timeline, giving us the reference of whether it is a P frame or an iframe in this case. And I can snap to this exact position in the file to find where this frame is by selecting my File Metadata button and choosing HEX Current Position. What that has done now is automatically opened up this reader here and highlighted for me that beginning of that pattern. So I see here the 00000167, followed by the 68, followed by the 06, followed by the 65, and then the frame starts. So if I go back to iNPUT-ACE, this frame right here starts right here. This is a helpful way for us to begin to understand what's inside of these files. I'm going to go back up to the top here again, and let's now look at the other kinds of frames in the file. So we've already talked about what the iframes look like in this particular file. But if I do a quick search now for the next instance of just 00000001, I can see that the next frame in the file doesn't have the 67 and the 68 and the 65. All it has is a 00000161 and then the data. And this particular instance here is a P frame. So if I search through the file now, I can see that the next frame is a P frame with a 61, the next frame is a P frame with a 61, the next frame again, and I can continue going through this file frame by frame by frame. And just looking at the hex values, I can see that all of these in sequence were each a P frame, and the iframe is going to come when that value changes to the 67, like we see here, followed by the 68, followed by the 06, followed by the 65, and then the data. So this is a very standard form of H.264. It's the most common form of H.264 that we'll see here. And let's look at a couple of additional examples of other files that follow that same pattern. Starting with one that has the extension .dav. If I drag this file into my hex reader, we'll see that the start of the file begins by spelling out the ASCII characters dahua, and that is the bytes 4441485541. If I dragged in any other number of DAV files that adhere to the same kind of format, we would always see the file start out with this dahua reference. So what does dahua mean? Well, if you don't know, you can simply copy that out of the file here by selecting it and choosing Control-C. And then I can even go into my web browser here and just do a quick search for dahua. What is dahua? And immediately we can see that dahua is a provider of video surveillance products. And if we read further about it, we would understand that it manufactures DVRs that are recording video. So without doing anything more than dragging and dropping this file into a hex reader, I already know the manufacturer of the file by just looking at the header here and doing a quick Google search. After that initial header reference, we have a large number of zeros. We can see that here is just 0000 all the way through the file. If I scroll down now, after that padding of zeros, now we start to see some data begin. And if I look, I can right away see that same pattern, 00000167, followed by the 68, followed by the 06, followed by the 65, and then data. So this here follows that exact same pattern. And I can do a search through the file again if I wanted to, and I could search for each individual instance of 000001 And I can see that the next frame is our P frame again, P frame, all the way through the file. So this is the exact same kind of structure of file, this Annex B H.264. The iframes look the same with their 6.7, followed by the 6.8, followed by the 0.6, followed by the 6.5. So the difference between this H.264 file here and this DHUA file is really nothing more than the header and some metadata in the file that we'll potentially talk about at a future webinar. But the data itself, the actual video content, the picture values, those are structured in the exact same way in both of these files. So let's take a look now at another kind of file, another standard type of file in the .264 format. If I drag that file in, now we see this reference in the header of MDVR96NT. Again, we could go Google that to learn more about what that might mean. And now we have a large padded section of zeros. I mean, there's a little section right here with some characters in it, but more or less there's a large pattern of zeros. And what I'm going to do now is hold down my page down key to go quickly through the file and snap all the way down now to where we get to our data. If I go back up now, we can see that the data starts right here. I don't see a pattern right now of that 00000167 anywhere in this. All I see is data just start to begin. So unless you already know, we might not understand what this content relates to. But let's do a quick search by hitting, again, Control F and searching for the next instance of 000001. Well, the next instance here is my 6.1, or my P frame. So I still haven't found an iframe yet. And if you understand the differences between iframes and P frames, which we go over in detail in the 2-day class that we offer, the full 2-day class, but if you don't yet understand the difference of that, what I will at least mention now is that in order to read a P frame, you have to have read an iframe to be able to understand what that P frame is. So if this file just simply starts with some data and then jumps right to a P frame, there is no way to decode this P frame at all. And if I go down to my next instance, I still see that P frame. My next instance now finally has that reference of 6.7, followed by 6.8, followed by 0.6, followed by 6.5, and then the frame starts. So if I were to drag this file into iNPUT-ACE, it's going to start reading it from this position here, because that's the first time that we have an iframe, and it's the first time that we have a frame that can actually be decoded by any decoder. But more or less, the pattern remains. It's following this same standardized pattern for Annex B H.264. All right, so now we have in our HEX reader here, we have 3 different file types, each with different extensions, each that more or less are the same kind of file under the hood. Before we go too much further, let's look at another kind of file. And in this case, what I'm going to do is bring in the .exe file for FFmpeg. It's a very large file. It contains everything to do with the FFmpeg binaries. It has no video inside of it. And my intent here is to show the difference between what standard video looks like and what things that are not video might look like. If we go through each of these 3 different files, what you'll see is even if you didn't look for these headers spanning the frames themselves, and all we looked for were the basic patterns at the ASCII level here, what you'll see is that there's a lot of variability and the data is quite dense. What I mean by dense is there's not a lot of space between the characters. We don't see much more than a couple of little periods before we have more data. And as I scroll down through this, I can't recognize any patterns. I don't see any information in here that is spelling out words. I don't see chunks of data that have any visible patterns throughout this. What I have is a dense, variable amount of data. That's what video looks like. And we'll see that when I go through any one of these different clips as I scroll down. We have dense, variable data all the way through each of these different files. Dense, variable data. On the other side of that, if I look at my FFmpeg file now here, the beginning of the file has lots of space between any of the characters. That is not dense, that's got a lot of space. So immediately looking at this, we can determine that there's no video right here. We can even see things that actually have text in them, like this spelling out of text, which again would be indicative of it not being video. Video is going to have pixels and pictures and macro blocks and motion vectors and a lot of other things that mean that the data is going to be quite variable. When I get down to areas like here that might look relatively dense, we can still see a lot of patterns. Like I see the character H being repeated all the way through here in a lot of areas. That's not going to be something that we would typically see at the video level because, again, it's going to be variable. We're not going to see a lot of repeating characters throughout this. As I scan down through here, I can see an entire row of data that is a bunch of capital letters. Again, not variable data. It's not changing rapidly. So we can tell immediately scanning through this that there's no video here. If I scroll down even further in the file, this might look like it's dense, but again, still we're going to see F, 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 F all the way through this. Again, it's not actually variable. There's going to be patterns that we can see throughout the file. And we can continue to see those kinds of patterns as I scan through this entire file. So even if we knew nothing else about the file, I didn't know what it was, simply looking through here and scanning down, we're going to see characters and patterns that can inform us that this does not contain video. Quick mention to make, just because we see something as dense and variable doesn't immediately mean that it's video. But if you see something that is not dense and variable, then it is not video. One of the common kinds of questions that we get frequently here in our office is from people that are new to the video world that receive a folder or a DVD or a USB with a bunch of files on them, and they want to understand if these are video, or potentially maybe they receive something that they can't get to play in iNPUT-ACE, and they're wondering, why can't I play this .vl3 file in iNPUT-ACE? Well, let's take a look at what this file actually is and why that might be so. If you receive a set of files like this, if it is going to be a video file, number one, we can look in HEX and observe those same things I was just talking about the dense variable data. But we can also look at the file size to help understand whether or not it could be video. Video is going to be quite large in size compared to other files. And so if I sort this folder by file size, I can see that my bin files are the biggest, then the VL3 files, and then these really small other files here. So what are all of these? Well, immediately, if I was assuming that one of these was video, by simply sorting by size, I can be pretty confident that if they're going to be video, it's very likely the ones of the biggest size. But I could go another level deeper, and I could actually drag these other files into my HEX reader here to see if they could be video, even though they're quite small. And again, using the same logic that we were talking about before, I can see characters spelling out different sets of data in here. I can scroll down and see patterns. I'm seeing these lines kind of striping across the video of the screen with space in between each of them. So scrolling through this quite quickly, we can make the determination that there is no video in here. We can see nothing but patterns and spaces between the files all the way through this. Without even trying to open the file, we can see that there's no video in here. The same thing can be said about these SL2 and UL2 files. If I drag those files into HEX, we see the same basic process. We see patterns and characters, and even though the file is quite small, we can also prove that it's not going to have video based on that understanding right there. Well, what about these .bin files? Well, if I drag the bin file into my HEX reader, now we see dense variable data. This, again, does not prove that it is video, but it definitely is indicative of us wanting to look a little bit further and try to see if we can get something out of this file. And if we were to drag and drop that file into iNPUT-ACE, we will see that, yes, it can decode the files and is able to give us the understanding of what kinds of data it is. And if we go back to our HEX reader here and we go back up to the top of the file, we can see that basic pattern again here of 00000167 followed by the 68 followed by the 65. This particular case does not have that extra value of 000106. We're not going to go into the details of what that is and why, but just know that it isn't necessary in order to be adhering to Annex B H264. So there we go. We can identify immediately that this does have video by looking at that header, by playing it in iNPUT-ACE, and using our understanding of the density here and the variability here to help us make that determination. So far, we've looked at some very simple examples of what video files can look like. Those are kinds of files that are common, but they are really easy to deal with. That is not what all video is like. Some video is going to have different ways of encoding. They're not going to have that same exact pattern. It does get quite a bit more complex from there, but that's at least a basic understanding of what the most common type can look like. Here's another type that goes another level deeper from that standard, and that is .exe files, where you can double click on the file and it can launch and play the file in a standard player. But the question here is this player playing it back correctly? Are we able to extract data from this appropriately? And what can we do to ensure that we're getting the highest quality footage? I've already covered topics like that in past webinars, so if you want to learn more about that, you can go to YouTube and type in iNPUT-ACE, and our channel will go into a lot more detail about that particular topic, and you can see that through the Digital Media Evidence and iNPUT-ACE webinar. In fact, if you're interested in learning more about the other topics that we've talked about as well with what H.264 can look like, I recommend looking at the Converting Video and Lossless Transcoding webinar that we ran within the last couple months. They'll give you a much better understanding of the kinds of topics that we're using today. But what we're going to do now is take this particular type of format and look at what it looks like in HEX to understand better how these EXE formats are being organized, to ensure that we're extracting out the best quality data, to ensure that we're viewing it correctly, and to really understand the organization of what it looks like at the binary level. So here we go again. I'm going to drag that into my HEX reader, and we can see that the beginning of this file, again, has spaces and patterns in it. And very commonly, these EXE files start out with the player. So the beginning of the file all the way through for a number of bytes are going to be just simply the UI, the interface that makes up that player. In this case, if I do a quick search for the hex value of 00000167, sure enough, I get lucky, and this particular file is adhering to that same standard that we were looking at before, where it has a 000167 followed by a 68 followed by a 65. So starting here in the file, and if we look at how far down we are into the file by looking at my scroll menu here, we can say that the data, the video data, doesn't start until here. Everything above this is going to be things related to indexing and things related to the actual player itself. So let's take a look now. If I go down to this area here where the video starts, I'm going to select right here, and by selecting this byte, I'm going to now scroll up to the top of my file, and holding Shift, I'm going to click at the very top. So what I have now is the entire player selected before I get to any of my video data. And what I'm going to do here is cut that data using my Control-X key. I've completely cut out that data and copied it. So now the file is going to start right from here, right from the start of the video data. And I'm going to make a new file where I paste that data in. So I've essentially manually written now a file that is just the player. So if I save this now, I'm going to name this here just player.exe. And I'm going to now save as this file as just video file.some extension. So what I've basically done is taken what was one file where the start of the hex was the player, the bottom of the hex was the video file, and I've split that into two files, one that's just the player and one that's just the video file. And if I double click on this .exe here, we'll see that we have everything that equates to just the player. I have all of my buttons down here, I have my save icons, everything that equates to the UI of this player. There's just no video here. We can't do anything with it. And now I also have a video file that I can drag and drop into iNPUT-ACE, and I could play that video file in here and see what the video looks like at its raw level. Now, what I've just shown you is not something that's necessary to do. Thankfully, with iNPUT-ACE, you can take the original .exe file and drag that directly into iNPUT-ACE. and you can interrogate that file here and have INPUT-ACE play that back for you directly, right from within inside the EXE. The benefit of which is that we are also able to give you the timestamp for that so that you don't have to look at a player for the timestamp. But I just wanted to show you what that file contains and how INPUT-ACE is doing that. We're essentially understanding that the beginning of the file is the EXE, jumping to the video data, and using the metadata to understand what the timestamp is. Let's look at another example of basically the same process. Here's another EXE. I can double click on this EXE. It's going to launch and play back inside of a player. We have a standard exact vision media player. We can play through the file. We can try to do things like extracting data. But is this playing back correctly? What's the appropriate size? That we might not know. So using the exact same methodology as I just went over before, let's take that file, drag it into my HEX reader, and we can see the same basic process. We start with some basic characters, it jumps into the player, and if I do a quick find for my video file, I can snap to my next instance of 000167. However, this right here, if we were to look at the ASCII representation of it, we can see a pattern. It's not dense variable data. So is that instance of 00000167 our header for the beginning of our iframe? The answer is no. We're not seeing that same dense variability here. This is just a reference in the file that's going to be something to do with either indexing or something else being used by the player to play back the data. So let's look at the next instance of the 000167. Well, the next instance now we see dense variable data over here, and we see 000167, followed by the 000168, followed by the 65, and now it looks to be data. So if I do the same process here, and I select at the start of my file, and I go up to the top here, and I just simply delete that data out, if I were to then save this file as just data.dat, what I'm going to see here is that my just data.dat file is going to be just that data. I could view that in something that I can understand that basic H.264 file, like dragging and dropping that into INPUT-ACE, for example. Now again, just to repeat, we don't need to do this process in order to get the data to play back in INPUT-ACE. We could just drag in that raw.exe file, but hopefully this does help bring better understanding to what's happening under the hood with these kinds of files. And in fact, if we brought in the exe file, INPUT-ACE would be able to read that much more quickly because we can basically immediately jump to that data. Oh, and excuse me, I must have copied some additional footage there by accident. So let me drag in the original raw.exe file directly into the file list. And let's look at how much better that is doing it this way. By simply pressing the interrogate button, we'll go through and automatically perform that process of carving out that data, knowing where the video data starts, knowing where the player starts, and then begin to view and look at the raw picture values in a way that can be used for forensic purposes. Now we can see what the actual pixel dimensions are. We still have our timestamp, and we can now use this in a much easier way. So if we were to start this particular file at the right byte offset, we'd be able to get this as well. But I'm running out of time here, so I'm going to move on to the next step. Let's delete all of this out and look at a slightly more complicated file type. Now we have here a file that is very similar to the first file we looked at. It's the same clip player. The UI looks very similar for the file. But now what we're seeing here is multiple different camera views all within the file. So this one is not going to be quite as simple as what we were looking at before. If we drag this file into our HEX reader, and I'm actually going to remove all these other ones here just so we can clean this up and ensure that we don't confuse. And I'm going to compare this multi-camera.exe with the single camera.exe, where the player was more or less the same kind of player. If I scroll down to the start of the data here, and I scroll down to the start of the data on the other file, as I toggle back and forth between these two clips, we can see that not really much is changing between the two files. If we look at the ASCII text over here, it shifts a little bit, so we are seeing some data change in the UI components for the player, but it does look quite similar. But with a multi-camera one now, if I do my search for my 00000167, and I snap down to the start of my iframe, we can look here in the text for the ASCII and see the reference for CAM8. So this is probably the first frame in the file is an iframe for camera 8. If I look at the next frame in the file, we see CAM5. And the next frame is CAM3. And then CAM7, CAM1, CAM2, CAM10, CAM12. So if all we were to do was carve this file out, it's not going to be easy to have this file be read by anything because it's going to jumble up that data and we're going to end up getting things that look like this. So I'm going to snap down to my first reference of my 6.7 here. I'm going to delete out this data back up to here, completely delete the file out. So my file starts at 00000167. I'm going to save this as a multi-camera file. And if we then try to play that multi-camera file in something like, for example, FFmpeg, what we're going to end up having is something that looks like this. A jumbled up mess of data where we're toggling between the various camera views, and it's not structuring the data correctly. We're not going through from camera 1 to camera 2 to camera 3. We get a jumbled up mess of data because FFmpeg doesn't have the understanding about what each of those frame organizations is supposed to be. So in this particular case, the best case scenario is to go back to the original exe, to take that original multicamera.exe, drag that file directly into INPUT-ACE, interrogate the file directly in INPUT-ACE, and let it go through and automatically parse that file into its various streams, understanding the references, understanding the metadata, allowing the user to then convert the files, do enhancements with the files, write reports with the files, and any other number of filters and advanced processes that you can perform within INPUT-ACE. So this is, again, a quick mention that there's nothing really that can be done with carving out that raw data unless you understand HEX in a much more advanced way and can do some more advanced carving techniques like doing things with Python or with other programming tools in order to get that stuff to play back. So here's what INPUT-ACE sees the file as now. We have each individual stream. We can toggle between the different streams. We can see each of the different camera views. And we can now use those, convert those, and read the raw data right from the raw file level itself. Okay, so let's look at one final example here. One final multicamera.exe example. If we double click on this, we have, again, our similar approach where we have a UI with multiple different camera views in it. We won't necessarily know what the right size is or how to handle this correctly. So the best case scenario is for us to go launch INPUT-ACE, drag that file directly into INPUT-ACE, interrogate the file with INPUT-ACE. It's going to go through and parse out those different streams, give us an understanding of what each of them are. Now we can read it, use it, mark frames, make subclips, convert the files, etc. For those of you who aren't as familiar with INPUT-ACE, I recommend watching the other webinars where we go into more detail about how we can do these kinds of things. But the quickest approach to get this content out is to toggle to the workflow tab, make a very fast workflow to convert these files to MP4. I'm just going to put these on my desktop, name the file stream, choose some basic settings that are going to ensure the integrity of the file, not adding any additional compression, connect the individual streams to the output, press execute, and in just a couple more seconds here, we'll have my desktop get spit with each of the 7 different streams that we can now double click on and play inside of a standard player. Okay, so I hope that you learned a lot about the basics of how to use HEX to understand what video files are, how to begin to look through a HEX reader and learn more about how they are being organized, what is contained inside, and gives you a better perspective on how to use INPUT-ACE to review that data and ultimately begin to learn how to do more complicated things with HEX analysis, like more complicated carving and that kind of thing. Okay, so we're right about the 45-minute mark, and we're going to open this up to some questions. And well, the first question that came in was, will H.265 temporal compression contain that similar patterning? And to be clear here, that basic pattern that we were referring to of the 00000167, etc., that's one kind of standardized pattern. It is not the only kind of standardized pattern that you will see within H.264. There's many other kinds of patterns. So this isn't a gunshot that's going to handle every single situation that you'll encounter. It's just the most common. I would say that out of the files that we get, probably a good 25% follow that kind of pattern. There's other forms of H.264, other profiles and levels that will change that, including other formats that aren't related to Annex B at all. I see another question that came in about if we are splitting the hex of a header from raw video to demonstrate how to open a video that's wrapped in an exe, can that be interrogated as is in iNPUT-ACE? And I think I've gone through and shown that, but the answer is yes. If you take the original raw.exe file, you can drag that file directly into iNPUT-ACE, and as long as it's a format that is integrated directly into the program, iNPUT-ACE will read that automatically. If you encounter in your analysis files that iNPUT-ACE is not reading automatically like that, we would recommend that you reach out to support and send us those files, because we can work to integrate those into future releases. Speaking of future releases, that's a good segue for those of you who are using iNPUT-ACE. We've got a really exciting new version that is coming out here in the next week. It's the biggest update that we've done to iNPUT-ACE since its launch. I'm really excited to show you. I'm going to save the explanation of what's actually in the program for another time. But we are going to be launching our brand new dongle licenses, our brand new light license, the brand new narrative report tool, and a bunch of other very exciting features in the program. So stay tuned. For those of you who are users of the program, you'll end up getting some really exciting new news here within the next week. Another question came in about the 2-day training class and how you can sign up for that. If you go to our website, which is also another brand new update from us here at www.inputace.com, we've revamped the website. It is now much more dynamic and flexible, and will give you the ability of signing up for these training classes directly. Here, let me use Google Chrome. If you toggle over from our website to our events page, the events page has a list of each of the different training classes that we're going to be offering this next year. One of the upcoming classes is a week-long class with the folks from DVR Examiner. Next month's webinar is about the basics of what that class is going to cover. So if you're interested in learning more about recovering video from a DVR directly, this is a great class. It's a full week put on by both DVR Examiner and iNPUT-ACE. And then again, next month's webinar will focus on the topics that we covered in that class, how to expedite your workflow by recovering footage automatically and putting it through the iNPUT-ACE process to write your reports and everything else. Feel free to give our new website a look over. There's some new information for you about basic features and other things that you can cover as well. Okay, another question came in about how to find information related to resolution and frames per second in the HEX editor. And unfortunately, it's not a question that I can answer in a 1-minute period. That's a much more advanced form of doing HEX analysis. So I'll leave that question hopefully for another webinar if we end up going into deeper detail about this topic again in the future. Okay, one of the questions that we see here is about a bunch of different buttons within HXD and what they all mean. So I'm going to very briefly, I'm not going to go into detail about this stuff. If you have specific questions about what the byte order refers to, like how little endian and big endian are interpreting data, I recommend going through Google and just reading some articles on that. I don't want to have to go through too long of a segue on that. But some of the additional features within here that you can use that will be helpful for you is setting your data inspector to give you an understanding of other kinds of interpretations of what the characters might mean. You can do that within your tools options dropdown, as well as you can do things like snapping to certain offsets by double-clicking down in the offset view here to snap to certain positions in the file. You can also do a number of other things like right-clicking in certain areas and selecting blocks so that you can understand where that particular frame is in the file. There's a number of other things, but I don't want to go too far into that. We go over this stuff in the 2-day class that we offer. So if you want more information about that, I definitely would recommend signing up for a full 2-day class. Okay, so with that, we are running up on the end of the presentation. If you have additional questions, please do not hesitate to ask them via email to our team at support@inputace.com. And after this webinar is done, there will be a survey that comes up. We would appreciate if you fill out the survey. It does help us ensure that we're providing you with appropriate information, going at the right speed, and any concepts that you'd like to cover in the future. So thank you again, everyone, for attending this free video training event, and I look forward to seeing you all next month.